So you set your
10 megaohm. Pardon me?
You set the pot to 0.
Yes.
Which pot was that?
That was the pot that was over here in the. That's just the span of the radiance, but I set that one to 0, so then I know what the resistance is. See, because otherwise, if it's somewhere in between, I don't know what it is.
Okay.
Plus, I want it low anyway. You want to talk to? Okay, we got that one in. Now, if we lock out, we got the right answer. Okay, now, should I have this at the right place here? Yes, I do. Now I should look at it. We're going to get that prism tomorrow or the day after. 1655. I can actually see it from here. 1655 is what it reads, okay? Of course, we're going to go on a computer to calculate that one. That's okay. So now, with 3.3 mega ohm, wall temperature is 1655 Fahrenheit. Let me just quickly convert that into centigrade. Another chair. That little thing. Not much at all. That wasn't enough. It's 1 degree. Still low. You know, sometimes it takes a turn or two before he kicks in. Still 1656. I don't know whether this is in between. Okay. 1659, we're getting there. I wonder whether this actually. No, we have 1667. Too much. Too much. Oh, you know, this we can do from the outside when it's all done anyway. You know, so I'm not going to be too fussy about that one. Let's see 59. You know what? I'll leave it because this you later when it's all together, you go to a furnace and redo this. You can do it from the outside. You don't have to worry or sweat it. Okay. Next thing is the emissivity. Okay. We can take the furnace away. We don't need that furnace anymore. Changing that resistor so drastically, it changed everything, including the zero. So the zero is too low. Now I'm going to adjust. This is the null adjustment for emissivity. I'm increasing it. Okay, 98 I got. Clockwise is increasing it. Okay. Counterclockwise is decreasing it. This appeared to me logically to do. Don't have to be too fancy because you may have to readjust it anyway. So it's 98.
Are you looking at the wall now?
Yeah, 98. Okay, now if I'm looking at the wall, Now I'm turning it back onto the paper. Pretty much centered on that little piece of paper there, that centerpiece, which is, you know, more wide, and I get 32, which makes sense. 34. Now, we have an option. We can reduce the resistor that we have in there, okay, the lower resistor, going by, you know, we have, if you look on the scale here, how much voltage we have, that's the way to do this here, okay. I have it clipped onto, right now here, I have it clipped onto the turret. By the way, let's just quickly check the, oh, I don't need that kind of intensity. Okay, you see, this is still the reference here, okay. Yeah, we have very slow speed here now, so we, okay. Now I'm measuring, it should be 1 volt. And let's see what it actually is, probably a good deal less. Oh. Well, I guess maybe I didn't, okay. That is, I would say the best thing is to change that resistor down there, and I'll tell you why. You see, you can also increase the, I can adjust the emissivity by the span here, but you know what you're doing is you have a voltage divider, cut the signal too much down, and then you use an amplifier to bring it up. That's not very good practice. The best practice is to adjust the voltage divider correctly, so you're close to the right number. So it was 34, 32, what did I say? 34. 34, this is a different kind of calculation. I mean, it's similar, it's related to this other calculation, but here's what we got. We got 34, emissivity, 34 means reflectivity 66, okay? Now we want to come up to 90, so we want to increase that ratio here. What is it? This thing here. We want to decrease, we want to have, first of all, let's see what is the R that's in there. Where's my, what's in there? Oh, this is R109. It's 21K we have in there, okay? So, R old is 21K. And we have to reduce that, so it's R new plus 2 divided through 21 plus 2, and this has to be less, is equal to 66 over 90. We'll explain that in a minute. 10% emissivity means 90% reflectivity. Okay, to really adjust the reflectivity. So, in 66 over 90 means this one has to be lowered from that level. So now we'll do this, let's see. We have R plus R new plus 2 is equal to 23 times 66 over 90. And then we'll take away this over here and we subtract that. Let's just calculate that. We can do on our homemade calculator there. We went through the radiance calibration, and we found, let me just get those numbers here from my sheet. We had the black body furnace calibrated to be at 906 centigrade radiance temperature actual, and the display showed 1856 Fahrenheit, 1855 Fahrenheit, excuse me, which is 1013 centigrade. That was for a 10 mega ohm feedback resistor with the pot turned all the way counterclockwise to 0. If you calculate the normalized radiance for the apparent, the display temperature, and the actual temperature, the ratio is 0.33. of the radiances. So the new feedback resistor should be 10 mega ohm times 0.333, which would be 3.33 mega ohm. We put in 3.3 mega ohm, and we got 1655 Fahrenheit, and we adjusted it up to 1662, which is equal to the 906 actual black body radiance temperature. However, since we had, well, previously we had adjusted the emissivity, but now that we have changed the feedback resistor for the DC path so drastically by a factor of 3, the emissivity gain, the gain for the AC signal also had been reduced. We had to recalibrate the emissivity channel. What we did is we changed resistor R109, which is part of the voltage divider on the F board, which is just ahead of the second AC amp. We adjusted it to come within range, and we calculated from the formula 3 of the description that the resistance, the R109 resistor, had to be changed from its old 36 kilo ohm value to something like 18 or so. Well, we put in a little more, put in 30K, so not to stay within a adjustment range. So we put in 30 kilo ohm, and now the emissivity reading was something like 34, 30 something. No, I'm sorry, it was 19, I think, 19 or 20.
16.
16? Okay, it was 16. So let me say this again. When we changed the resistor R109, which is part of the voltage divider that divides the AC signal down before it goes to the AC amplifier, we changed that dividing resistor, the R109, from 36 to 30K, and now the emissivity, which had been 34, 33 for the white paper, now was 16. And then we adjusted the span to bring it down to 10. This a little bit of the way here. That's that. This goes in here. This goes like this in here. Should do it so that the wires, are sort of down here because they have to be placed. Okay. Actually, I could use a little heavier duty yet than this one if we have it up there. It's sort of like in line here underneath. Okay. Now let's get rid of things here. Okay. And now let me just mark where the tabs are here.
You don't need the null?
No, the null we have to, the null we have to black out. It's not needed anymore. Not for this good. It's one of the See, so it goes off, target temperature, wall temperature, measure E, set E, max, average, and that's it. Doesn't go, what? Oh, I see what I did.
So you have to adjust the.
No, I have to. Okay, now. Okay. Off. Target. Temperature, wall temperature, measure E, set E, max, average. That's it. No more. Okay. This is correct. I got them right. All right. Now, this tab has to engage this hole. Okay, so I loosen this all together. I make sure I don't disturb the stop tabs too much. So I go in here. This is a bit tricky. See, I got it in there already. Okay, I've done it already. Okay, fine. Now,
And which part did you say had to engage? You said the tab?
There was a tab underneath on this thing which had to engage into a hole in the casting. Right now what we do, we don't fool around, we just cut them short and restrip them. Also make this 26. I make it sort of 3/8. The reason being that I want it to stick into the terminal.
So you want them tinned?
Yeah, I want it tinned. Just lightly. Okay. On top of everything else, I take the tip off because it's only so little fat on the tip. Snip it off. Same here. Sort of seems to run to the end. Okay, then you do the same thing here. Make this a little shorter. This is actually 26 gauge. Well, it's more, huh? You know what? It looked like I clipped a couple of wires here. Try 24. You know what? I don't know what that is, but that gauge. Alright. These haven't been clipped yet. Okay. I'm going to clip them here. This one here. And I'm going to do 24. That works fine. Start putting things in. Three is this here. Too much, too long a little. Remember, I put some of this. What is this stuff called here? This tape, this insulating tape. You know, it didn't short. This one here, and then we're done. Again, let's check. This is tight. Good. Okay. I gotta hit this white wire, put it all the way underneath here, onto this wiper arm. Okay. So while I'm moving Oh, this isn't tinned all the way down. Where is it? Put it behind here. Now, see this here?
You don't want it tight?
Not too tight, otherwise you can get the second half. If the second half is not exactly lined up, you can't get it over. See, it jams, but see, this is a lock washer that gives him some movement. I don't want to do it like this, I want to do it like that. Oops, we'll put that garbage. Can you move over a little bit so I can get there? Okay, yeah, put it in there. Okay. That's fine. Okay, now we got to get a battery on there. Put it here. Okay, this wire goes to over here. This the battery is positive there. And it's negative here, the battery. You look at it, at this thing. Okay. I'm trying to hold this without touching the clip though. Now I have to really look upside down. 1661. Now to the next position, which is I'm going
wall
from here counterclockwise. No, I went from wall temperature measure E now.
Okay.
So now I'll put this back on. It's not good practice. You'll have this thing that moves in. I've already centered it. Tried to center it on this thing, but it's too high. So I'll go lower. This is correct.
You're looking at
now,
You're looking at the card now.
I'm looking at the card now, right? And I'm gonna see a number here. Okay, it's okay. This could be in this position. Okay, fine. We are here. We are in clover. Okay. Just to be sure that it also works the other way around. Do we have a recoil? Yes, we do. Fine. Okay. Good. Everything is co-sympathetic, as they used to say. Fine. Sit. Now the question is to close it up, but I'm not going to do that today because I have to leave.
County Service Department, how may I help you? Yes, hello. It's about time. Absolutely. We'll check that out when you come in. And I'm just pulling up your record here. Of course, Danbury County routine maintenance is no charge for 4 years, 50,000 miles. Yeah, I like to get people to
use this.
7 a.m. on Monday through Saturday. Okay. Okay. We'll see you then.
So far, so good. I mean, we have to see, you know, it's like some of these things, have to see how it holds up in the field.
Seasonal attitude disorder into overdrive.
You can always go to Crazy Glue. We used to have a black Crazy Glue from Loctite. That was pretty good. That fits perfect. Okay, let's put it on. We'll put it on a. Remember, it was in this fixture with this side that is below now here, horizontal, and this one up vertically, and it was secured with two 440 screws. Take out the screws, put this in carefully, lay the wires around the outside, and then very carefully close it, making sure that you catch the switch and this nut, and the you close it around the shaft of the multifunction switch. So this push button here, you have to make sure that the lock washer is on the inside. All right. Very careful. Make sure you don't catch any wires. Just what I use a very thin steel ruler to just poke around the edge. Make sure there's no wire caught in between. Has to go together nicely without any force. Then you tighten you put in 440 screws, 3/4 inches long, and you put them in evenly. And again, not too much force. If you have too much force, you got a problem. Just go together, hand tight. Then I added the inner cell was attached with 2 screws before, so I add 2 more screws. These are 256 flatheads. They're 1/2 inch long, and I sharpened the point to guide it into the feet. Next thing is to put on the plate, the function plate. You take off the knob. Right, I'm sorry, the knob isn't even on there. You take off there's a nut that holds down the shaft of this multifunction switch, a rotary switch. Take off the shaft, put this thing on, slide it over, put hand tight or very loosely tight the hex screw that holds the shaft in. Take these 2 decorative screws, they're 0.80, 1/8 long. Put them in here with a little Loctite. Don't suck it down, let it a little loose, so you have to align the other side. I hold it with a tweezer and then with a small screwdriver. Then you tighten those. Once they're in, you tighten them. Then you tighten the hex nut with an adjustable wrench. Then you put the knob on with a socket set screw in there, socket head set screw. Tighten that. Next thing you do is you put the battery in. If the battery snap, put the battery snap on the battery holder, guide it in, then you put the door in. Well, the door has the rubber glue to the metal part first. Then you put this door in first, this shoulder screw, this brass shoulder screw. I've forgotten this. I think it's 832. And then you have a captive screw here. This is the screw that you take out when you open, you pull it up from here if you open the door to change batteries. That's captive, meaning that you can't get lost theoretically. Next thing is you have this in already. This is called the D-ring here. Is you put the other D-ring in with a 632 screw, Loctite of course always. Then you put on the this is protective glass for the viewer. You thread that one in, and you put this rubber washer ring, which has a double-sided, it has a adhesive backing. Put this around tightly. Put in so not the 4 screws, not yet. You put the what's called a body bumper in on here. These 2 body bumpers. You put the front bumper in. I use Loctite for that. It like drops the Loctite all around in the inside, and then push it over. Make sure that this is hanging down. Of course, this has to go like that. Then you do the final adjustment, emissivity. This you don't touch. Theoretically, that is the radiance null, but you don't touch that. Emissivity null and emissivity span. Those 2 you adjust. Looking at infinity for the null, and at the magnesium carbonate target, you set it to 10. We have to have that recalibrated. The reason why I'm not 100% sure is because dust gets on that calibrating surface and changes emissivity. So theoretically it should be 5 when it's brand new, but I think this has been oxidized and this is more closer to 10. You have to have it calibrated. Then you adjust. When you go to black body furnace, around 1,000 degrees centigrade is fine. You see whether you have to adjust the temperature. By the way, you go into wall temperature mode to do that, because that just measures radiance temperature. Put it in there, push the button, and then read what the black body temperature should be, and you can adjust, do fine adjusting of that reading if you have to.